Hello and welcome to GeNa. In this video, we'll be looking at the concept of decorators when structuring our game objects so we can spawn things in a very logical way. To use a decorator system, we're going to be using the following workflow. Number one, create your prefab. I'm going to use this house as my prefab I wish to spawn. And then next, what you'll want to do is attach and modify a decorator component. You can look for them by typing in GeNa Decorator. There's quite a few decorators that come with them. We're going to look through each one of them throughout the video. But at the moment, I'm going to just test this by using the transform decorator. It should modify the resource in the spawner. So I'm going to select snap to ground, and I'm going to lower the position so that it embeds into the terrain a bit nicer. So I'm going to lower it down to -1, and I'm going to lower this to -0.5. And that should be it. Then what we do is we create a spawner. I'm going to use a default palette. And I'm going to just click and drag this prefab into the spawner. If we open up our resources, you'll notice that the position modifier has been modified and we have our snap to ground. So when we go to spawn this object, those settings will be applied. If we want to update this information, we'll have to go back to the prefab, update the prefab's decorator settings, and we'll need to re-import it back into the spawner. And there you have it. Throughout the video, we're going to be exploring all of the different ones that GeNa comes standard, and I'll also show you how to create your own custom decorators through the API. Going back to our game object, let's take a look at the spawn criteria decorator. So firstly, I'm going to remove the genus transform decorator, and I'm going to be adding the spawn criteria decorator instead. As you can see, you can modify any one of these spawn criteria checks, and it will change the way that it works in the spawner itself. So let's go ahead and change check collisions to none, so that this object will ignore all collisions upon spawning. So I'm going to go back to the spawner, I'm going to remove the prototype, I'm going to re-import it again. So as you can see, it has successfully modified our spawn criteria override in the advanced settings. This means that every time we spawn, it won't use the default collisions for this specific prototype. You can see that the offsets and everything that's happening allows it to intersect. Let's consider the following scenario. So say I wish to create a spawner that spawns unique villages onto my terrain. GeNa Pro actually allows us to achieve this kind of functionality through decorators. So looking at the way I've set this up, our houses are set up as separate objects that contain all the bits and pieces surrounding the house, and I've attached a chance of decorator to each of them. Each of the chance of decorators have 75% of a success rate to spawn. This is so that we can add variation to our spawns. If I go into one of our houses here, you'll notice that I have houses, fences, and details. Now, houses contains a whole list of game objects, in this case, different type of houses located in the same position, which explains why I'm having a bit of Z fighting. This is totally intended because I'm going to be using the one Child Of Decorator to select one of the objects depending on a single weighting. Now the weighting is set to 111, which means that each of these objects are going to have an equal opportunity to be selected upon a spawn. If you wish to have, for instance, Gaia House spawned a majority of the time, you can lower these other two as their success rate will be less. And seeing as though their success rates are less, then this one is the more likely output. Moving right along, we have our fences and our details, which I've attached to each one of the fences a transform decorator that snaps it to ground. And the same goes with the details. The same layout is applied to each one of these houses. So let's go back to our scene And let's create a new spawner. I'm going to use the default palette, or you can create a new one. And I'm going to import the medium farm prefab. Upon importing, you might notice that the object has been treated as a single prefab. This is not what we want, as it will spawn each one of them the way that it was laid out originally. Instead, what I'd like to do is I'd like to tell GeNa that this prefab will need to be unpacked so that all of the decorators inside are used. This is because of Unity's nested prefab system. In order for us to support the nested prefab system, we will need to tell GeNa to unpack this prefab so that we can treat each one of these game objects as a single resource. So to do this, I'm going to add at the root level a component which is going to be called a Prefab Unpacker Decorator. Save your prefab, go back to the scene, and re-import this asset. Now that we've added a Prefab Unpacker Decorator, it has unpacked each one of our objects and applied all of the decorators to them as well. And notice how all of our villages are unique every time we spawn. The more game objects you add to your prefab, the more variation you will achieve. One of the things I want to do with this spawner is flatten the ground underneath the village so that all of the objects are sitting realistically on top of a flat environment. So to do this, I'm going to go to the medium farm prefab and I'm going to add an empty game object to it. I'm going to drag it all the way to the top and I'm going to call it flattener. The reason why I'm putting it at the top as opposed to the bottom is spawning prefabs in GeNa works top down. So the flattener will be first, along with the house and all of the houses and fences, etc. So we're going to add a component which is called a GeNa terrain decorator. And we're also going to select a brush that we can use to flatten the terrain underneath. Now, in order for us to detect the flattener works on the terrain, we're going to exit prefab mode. We're going to drag the prefab into our scene, and we're going to select the flattener inside of it. So this is going to give us a visualization of how the flattener will work. And already the problem I can see is that the object itself is not containing some of the objects. So I might have to increase the size of the flattener. But before I do this, I'm also going to make sure that there's a bit more of a fall off in the end, and I'm going to increase the area of effect size. So if we go around our object, we can see that everything seems to be housed within this flattener. So once this is done, I'm going to apply my prefab. I'm going to delete it from the scene, and I'm going to re-import it into my spawner. To test that this worked, I'm going to take a look and see the flattener object has been indeed imported with the flattener information. So if we go ahead and spawn another one of these villages, you'll notice that underneath the village, the entire thing has been flattened. Every time we spawn, the area underneath will be flattened. You can also change the strength and increase the area of effect to the desired output. Let's consider this other scenario where I want to spawn a series of rocks into my terrain, but I want to simulate it as if it physically spawned there. This is where the physics decorator comes in handy. So the first thing I'm going to do is I'm going to grab a rock prefab, which I've called stone in my project. I'm going to get the stone prefab, and I'm going to attach a physics decorator component to the object, and then click apply. Now that I have a physics decorator, I'm going to go ahead and import it into a new spawner. I'll use the default palette, and I'm going to click and drag the stone into the spawn prototypes. Upon ingesting, you'll notice that this particular decorator doesn't modify the individual object itself. Instead, if you scroll up to the top of the overview, you'll notice we have physics type, iterations, step size, and spawn offset exposed. The reason for this is because a physics component could apply to multiple objects within the spawn, but we can also choose to perform the simulation via resource. Let's leave it with the default values and try to spawn our object. You'll notice that the object spawned and it performed a physics operation on the object. So as the object is moving, it'll continue to perform the spawn operation. But once it stops moving, the spawn is finished. You can increase the step size to increase the speed, or lower it to decrease the speed of simulation. Next, I'm going to apply a spawn offset so that the object will spawn above the terrain to begin with. I'm also going to increase the instance count to something a bit more significant and increase the throw distance so that the spread of the objects is varied. And here we have our physics spawn. Let's consider this other scenario where we have our terrain trees as prefabs. And we've created a layout with our prefabs, but we want to spawn them as if they were terrain trees, but with the same layouts. This is also made possible through the use of decorators by going into the prefab, opening up a particular tree prefab, and adding a terrain tree decorator. This decorator converts the prefab into a terrain tree resource in a spawner. So let's go back. Let's create a new spawner. And let's go ahead and add the prefab to our prototypes. Upon adding, you'll notice that you have a little T symbol where the trees are. So this has actually converted this prefab into a terrain tree. And next time we spawn, those particular objects are terrain trees. With decorators, we can also change the tags and the layers of the object as we're spawning it. For example, if we have our house over here, we can attach a object layer decorator to this object. We can change its tag to a building and a layer mask I'm going to set to medium. Once you apply this prefab, we can add it to a spawner. And as we spawn the object, our tags and layers will change. We can also change the spawn flags of the object by dragging out our prefab and attaching a spawn flags decorator to our object. Here we can toggle on and off some advanced settings that we have in our prefab resource. Once you change some of the values, if we apply this prefab, go to a new spawner, we can import it into our spawner, and you'll notice in the Advanced tab that those settings have changed. Now we're going to learn how to make our own custom decorator by using the API that comes with GeNa. So let's go ahead and start creating a script. We're going to call this script Growth Decorator. And what this decorator will do is when we perform a spawn, it'll start to slowly animate the growth. So let's open up our script and let's go ahead and remove the start and update functions and any unnecessary namespaces. And we're going to go ahead and use GeNa.core to access the iDecorator interface. Now by default, you're going to get errors because you need to import the missing members, which are onIngest, onSelf-spawned, onChildren-spawned, and an Unpack prefab property. We need to remove the not implemented exception for these. And to go through what each one of these do, let's start at the onIngest. When you click and drag the decorator into the spawner, this method will get called, and you can modify the resource however you wish. In this case, we're not going to need this, so I'm just going to leave it empty. I'm also going to create two public variables, one called start scale, and I'm going to set it to vector 3.0, so it starts at nothing. And I'm going to create another one called end scale, which is going to be set to 1. Next, I'm going to create an IEnumerator which will be our growth coroutine operation. And the way that this is going to work is it's going to start with a float time, and while the time is less than or equal to 1, so while the time is below 1, I'm going to lerp the local scale by start scale and end scale using time. And we need to increase our time by delta time. And we're going to yield a wait for end of frame. So basically this coroutine will, every frame, increase the scale by a timer, and it will wait for the next frame to do the same operation the next time. By the time the timer reaches 1, it will exit this loop. So all we have to do is when we spawn the object, once itself is spawned, we're going to yield return grow. And this will perform our coroutine operation. Next, we have an onChildrenSpawn function. What this will do is it'll run when the children have spawned. We're not going to currently use this at the moment. And we also have a bool that suggests should we unpack the prefab or not. By default, we want to set this to false because we don't want to unpack the prefab unless we attach the unpack prefab decorator to the game object. Let's go back to Unity and let's start to use this decorator. So I'm going to grab my random game object and I'm going to attach the growth decorator to this object. I'm going to click apply and I'm going to remove it from the hierarchy, and I'm going to create a brand new spawner to store this object, and I'm going to click and drag that object into the spawner. So it should have our decorator on it, and the way we test it is by spawning. There we go. Now I noticed that when you spawn, there's a little flash of the scale. And I think the reason is because we need to change the scale at the start of the coroutine before it gets run to mitigate that problem from happening. So let's go back to our script. And when we're about to do the self-spawned, we're going to change the transform.local scale to vector 3.0. This will zero out our scale before it even gets into this coroutine. Going back to Unity, let's try and do it again. And there you have it. This is very useful if we use it on trees, so we can see it spawn during runtime. If we increase the instance count and the throw distance, you'll notice that when we perform the spawn, it'll do it individually and wait for the next process to happen. If you want to perform the coroutine in parallel, go back to the script and perform a coroutine by using GeNa's events start coroutine. This method allows you to perform a coroutine both at edit mode and runtime. So be sure to use this instead of Unity's start coroutine method. We're going to call grow as our first argument, and it needs a mono behavior to attach to, which is going to be this mono behavior. And now we can yield return null, which will skip a frame. So let's go back to our game and let's perform our spawn again. Each one of the objects should spawn independently. There you have it. You can also control your speed by timesing a value by delta time. So we're going to use scale speed times time.delta time, which is initially set to 10. There we have it. If you wish to learn more about creating your own custom decorators, be sure to check out the documentation in the folder. Thanks for watching, and stay tuned for more videos on GeNa.